Hey guys, how are you? Welcome back to the channel. Today is day 41 of Upskilling myself, and today I solved 4 DSA problems. And for the DSA part, it was quite a productive day, and I also did some internship work and stuff. So yeah, let's see the DSA problems that I solved. So the first problem is merge to sorted list. So we have been given two linked lists, and we have to merge them in such a way that the list that we get is in the sorted order. Okay, so how to solve it? So we can solve it using the iterative way as well as the recursive way. The iterative way uses space complexity, whereas the recursive way does not use. Okay, so we'll solve using the recursive way. So this is the base case. If there is no list 1, then we turn list 2, and if there is no list 2, then we turn list 1. Fine. Okay. Now if the first node value of the list 1 is less than the list 2 of val, which is the first node of the list 2, then we set this, which is the node of the first linked list, as the starting point of a new linked list. Okay, else we set this as the starting point of a new linked list. Okay, so in this case, list 1 of next will be merged to list. We'll call this function again, and we'll pass list 1 of next and list 2. So when we call the recursive function again, this will be the first node of list 1, and this will be the first node of the list 2. Else we do the same for the list 2. Okay. So the second problem was decode string. So we have been given a string. You can see over here. Let's say 3A 2BC, and we have to decode it. So it's like 3 times A. So it's A 2 times BC. So it's BC and BC. Right. So how to solve it? So to solve it, we create a stack with pair of string and int with current string and current num. Okay. Then if the character is a digit, then we set the current num as digit. Else, if it's alphabet, then we add it into the current string. Then now, if it's an opening bracket, then we push the current string and the current num in the stack and set them as 0. Then if it's a closing bracket, then we process it. Then we get the top from the stack and as previous string and number, which is the multiplier. Then we create a decoded string to store the answer, and then we set the previous string plus decoded string as the answer, because the previous string is the string that we already got from here, and this is the processed one, the decoded one, right, for every operation over there. So we create a stack, we create a current string as empty, then we create current num, then we traverse the array. Then if you see if it's a digit, we convert to int, and then we set it as current num. Then if it's an opening bracket, we push the current string and the current num in the stack, then we set both as empty and 0. Okay, else if it's the closing bracket, then we process it. So we get the previous string and multiple from the stack of top. The current string will be previous string in this case, and the multiple will be how many times we have to multiply. Then we pop from the stack, then we create a string called decoded, and while the multiple is still there, we add the current string into a decoded one till there is multiple. Okay, then the current string will be previous string plus the decoded one. Okay, else if it's not a closing bracket or opening bracket, then definitely it's an alphabet, so we have to add the alphabet into the current string, and finally we return the current string. So the third problem was random pick with weight. So we have been given a 0 index array of positive integers w, where w of I describes the weight of a ith index. Okay, so there's nothing but what we have to do is, let's say we have been given an array 1, 2, 3 and 4, right? We can return any index, and we have to also consider the probability. Okay, so we create a prefix array which will store the prefix sum. Then we create an integer total. We resize the prefix according to the size. Then we set first element as the first element of w. Then we traverse the array and add the elements into the prefix vector. We will add the prefix dot back as the sum of the total elements. Then in this function over here, we will set the random value as the random modulus total plus 1, so it will be in the range. Then s will be 0, a will be prefix size minus 1, the regular binary search. Then while s is less than e, we will get the mid, and if the prefix of mid is less than the random value, then we will set the start as mid plus 1, else we'll set the end as mid, and then we'll return the s. Okay. The final problem was median of two sorted arrays. So we have been given two sorted arrays and we have to find the median. So let's take an example of 1, 2, 3, 4, and 5. In this case, this will be the median, right? But in the case of 1, 2, 3, 4, 5, 6, these two are the median. So 3 plus 4 is 7, and 7 by 2 is 3.5. So we have to return 3.5. But one thing to remember here is these two are different arrays. These two are not single array, right? And we have to also solve it in O of log m plus n time complexity. So you can't just merge arrays and sort them again, because sorting takes n log n time, right? So this is not valid. So how to solve it? So to solve it, we use binary search on the smaller array to partition both arrays into left and right halves, so that all elements in the left are less than or equals to the elements in the right. Okay. Then we ensure the left half has exactly half of the combined elements or half plus 1 if the length is odd. Okay. Then we compare border elements to adjust the partition until it's correct. The median is then the average of the max of the left side and the mean of the right side. Okay. So we define n1, n2 as a size. Then we want to use the binary search on the shorter side. So if n1 is less than n2, we find the median on the nums of 2 as n1. Okay. Then we get the total size, then low and high. Then we get the remaining elements from the symmetry. So left will be n plus 1 by 2. Then we will do the binary search. We'll get the mids and boundaries. So mid 1 is low plus high by 2. Then we'll get mid 2 as left minus mid 1. Then we'll get L1, L2, R1, R2 as int min and int max initially. Then we'll set the boundaries. We'll set R1, R2, L1 and L2. Then we check for the conditions. If L1 is less than or equals to R2 and L2 is less than or equals to R1, then it's valid. And in the valid case, if it's odd, then we return the maximum of L1 and L2. If it's even, then we'll return the maximum of L1 and L2 plus the minimum of R1 and R2 by 2. Okay. And then if it's not valid, then we change the half. If L1 is greater than R2, we'll set the high as mid 1 minus 1, else low will be mid 1 plus 1. And finally return the 0. Then for the development part, I did some internship work and did the revision of all the DSA problems that I solved till now. So thank you guys for watching and see you on day 42.